So why did I put our order of operations and not the order of operations? Yeah.
We don't follow PEMDAS exactly.
Well,
Switch it up.
can you follow PEMDAS exactly?
No. Well, yeah, you can, but I don't know.
Yeah, I don't know. That's kind of the point about that. Because it's just an order of operations. We could make the order of operations anything we want to, and it wouldn't be wrong. It would just be the order of operations that we use. We could do addition first before multiplication if we wanted to. It would seem a little weird if we started doing that, but after a while, you would get used to it. So we just decided that we would follow this order of operations, and that is to say, parentheses first, which just makes sense, because if I group things with parentheses, it's a pretty widely recognized way of grouping stuff together. Draw your attention to it. Exponents, we want to do those next, which is just a higher form of multiplication. We come and do multiplication and division next, and addition and subtraction. That's just how we decided to do it. We do multiplication and division from left to right, and we do addition and subtraction from left to right. So according to that, what is the first thing we would do? Parentheses. So what's in the parentheses is 6 minus 3.5. What's 6 minus 3.5? 2.5. We're gonna. Okay. So now we've rewritten it. We can combine the things that are in the parentheses. All right. Any more parentheses?
Yes.
Yeah. Kind of. Do we really need to write these parentheses?
No.
No, but they work fine. You know, there's a number and I want to square it. So so we got exponents next. So what does that mean we're going to do? 2.5 times 2.5. 12 times, what's 2.5 times 2.5? 6.25. That's 1.5. What's next? Multiplication. 12 times 6.25. What's 12 times 6.25? 75. 75. Minus 1.5. Now we're down to subtraction. 73.5. Okay, on down to here, we're multiplying some numbers together. We could do it different ways. Like, how about, let's think about the negatives first. When you do a negative times a negative, times another negative. Negative, okay, well, we make sure our answer is negative. When we multiply fractions, how do we multiply them? Straight across. Okay, so we could multiply straight across and get these pretty massive numbers. Or, before that, we could recognize, we're going to talk about this at length today, but we know that if we're going to cancel things out, they need to have common factors. If we multiply all these together, we'll just have this one big uber number that has all the factors of all these numbers in it. So we could just go back here. It's like, it's kind of factored out quite a bit at least. Back here, whatever that big number is, it's kind of factored out. And look and see, if all these factors are going to go together, these factors are going to go together in these two big numbers, then we can just look at the factors and see, what is this, the V-share factors, B-share factors, right? Save ourselves a little bit of time rather than getting these big numbers and having to simplify at the end. So we call that cross-canceling a lot. Anything that can be cross-canceled? Hildy? 3 and 3. 3 cancels with 3. 3 divides by 3 and you get 1 for both. Any others? Other numbers that cancel? Yeah.
4 and 8.
4 and 8, sure. 4 is divisible by 4 and so is 8. Divide 8 by 4 you get 2. Divide 4 by 4 you get 1. Okay, so we have, when you cancel out that 3, what's left? 1. Sometimes I see 0, so to make sure that it's 1. We divide 3 by 3, and we get 1. So we get 1 times 1 times 2, 2. And 1 times 1 times 9, negative 2 ninths. We made sure that it was negative at the beginning, so we took care of that, so that should be right, negative 2 ninths. have to do first here? Huh?
Could you change one, like 1/5 into 0.2?
Oh, let's not do that. Let's not turn fractions into decimals, especially right away, and also never. Okay. Let's not be afraid to deal with that. To deal with fractions, you're gonna have to deal with fractions. You will have to do it. You can't avoid it forever. Okay. So don't just turn it into a fraction and then plug it into your calculator. Please, pretty please don't do that. Okay. So leave it as a fraction. What do we do first? Yes.
Wait, what was the question again? Sorry.
What do we do first? Is there anything we have to do first? We have a choice of what to do first.
Go left, right.
Left to right is a choice. We could also start here. We can multiply these together. We have associativity. We can multiply them in any order we want. But left to right is fine. So we're multiplying 1/5 by 10. Negative 1/5 by negative 10. Okay, so the answer will be, that part will be positive. How do you multiply 1/5 by 10? How do we multiply? Put what over what?
10.
Put 10 over 1? It's the same, right? 10 divided by 1 is 10, but now it's a fraction. It's easier to look at or work with if we're dealing with fractions. Okay, so we get 10 over 5, which is? Just what? It's just, so how far away are you people? I can barely hear you. 2, I heard a 2. I'm just going to run with it. 2, positive 2, times 4, times negative 5c. Let's see. And then 2 times 4 is 8, times negative 5c, negative 40c. So we're going to use the distributive property. What does that mean? Like, what does that look like to use the distributive property? Take this and do what? What do we do? Yeah, you take this and you multiply it by each thing in the parentheses. So you got negative w times 2w. Okay, let's see what that is. What's negative w times 2w? Yes?
Negative 2w.
Is it negative 2w?
Negative 2w squared.
Squared. Okay, that's very important. Because the way it was, that would just be negative 1 times 2w. That would make it negative 2w. Right? Somebody explain why it's w squared. Ethan, I saw your hand go up. Now you can't back out. Okay, there's 2 w's. But there's 2 w's here, aren't there?
Yeah,
Okay, well, what's the difference?
there's not a 1 in front of the other two, but there's not a number.
Nathan.
Okay, well, the 2 in front of the w, that's 2 times w, and
Yeah.
then there's w, that's times w.
Okay, so you got 2 times w, which really means there's 2 w's, right? In what way? Like, how are those w's being combined? Here's a w, here's a w. How do we put them together so we write it shorthand 2w? Nathan?
W plus w?
Yeah, 2w means w plus w, and w squared means w times w. And that's what we're doing. W times w is w squared. So negative w times 2w is 2w squared. All right. And what is negative w times 7?
Negative 7w.
Negative 7w. There it is. Negative 7 of the w's. You put these together, add these together, you get like negative 9 something. Negative 9w. Negative 9w squared. Can we do that? Right, can we put these together? Negative 9 something. Negative. No. Why not? Huh?
The other W isn't squared, or?
There's a very, at least I know I can't do it, because the other W is not squared. Okay? So that's a reason enough to not do it. Can we go deeper? Can we explain that more? Yeah, they both need to be squared, they both need to be the first power. Yeah, they are officially different things. Okay? They're different variables, so you cannot put them together. This represents a completely different quantity than this. So I can't just put them together, add them together. Because, let's see, let's jump over here real quick. I can represent W with a single length. Is that okay? Did W represent a length, like W inches long? Okay. So if I make this length also W, and this length also W, okay, here's one way. If this is W and this is W, if I do W times W, I get W squared, and we can see, like, W squared has like a second dimension to it. It's just isn't comparable to what W is if I'm trying to add them together. Okay. Now there is a way I could multiply these together. I could take this length W, and if we look at an angle, this length W, and then I can multiply by this length W, and now we get W times W times W. That's W cubed. That's all W cubed would mean. It would be W times W times W. But to do W plus W squared, they just don't link up. There's no way to connect them with addition. So leave them alone. Need the same variable, same exponent on the variable. All right. Now down here for 37, what's the first thing we're going to do as we try to simplify that expression? Distribute 7, and we get what? Okay, I'll read your lips back there. 7W. That's all we got so far. Yeah?
7W minus 35.
Minus 35. Plus 3W. Can I put the 7W with the 3W? Can I add them together?
Yeah.
Yes, I can, because they are like terms. So 10W minus 35. Any questions from this quiz at all? Any questions from the homework? Someone asked me a question at the door. That was good. Does nobody else has any questions at all about the homework? Any way, shape, or form? This for me. Then let's vote on the homework, please. Just hand one out. Okay, we're gonna exchange pieces.
What in the world is
It is a weird.
Yeah.
And I'm missing one today.
What in the world is going on?
So I should go read it.
Kid gets arrested at school.
Oh, yeah.
School. By Mr. Bell. Okay, so
Last
actually,
time he wasn't here.
Probably wasn't. What do you have? Probably.
Yeah. I'm guessing he's just
put him on the bus.
Pass him down, please, Ethan. Pass him. Everybody get one? Okay. Oh, drat.
Okay.
All right, today we're going to, again, we've done this before, but we're going to divide by fraction. We're going to talk about which of them are you supposed to use the reciprocal of. I'm going to simplify what I'm calling an algebraic quotient. That would be a fraction that has variables in it. Okay, so there's like variables up in the numerator, and there's a denominator with an integer there, and we have to simplify it. Okay, that's going to possibly take a while. We're going to really talk about simplifying a fraction and the definitions of some really important words. Go look at can you divide by 0. I hope to watch a video about that, and I think that's where we'll stop today. So we'll see where we get. Maybe we'll get further. Maybe we need to. So 2.6. If you want to get the most out of this class, is just participate. Offer up answers, ask questions. Don't talk to each other unless you feel like you're going to get a good explanation from that person and it's not going to distract the class. But if you do have a question, you should be asking it. If you have other stuff to discuss, that's not what class time is for. Okay? Playing games on your calculator and showing each other funny things, that's for other times, maybe on the bus, or maybe when you get home, you're hanging out, or whatever. But when you're here in this room, it's time to learn math. When you're in the English room, it's time to learn English. And when you're in the history room, it's time to learn history. Okay? So if you want the most out of it, don't take away from it by doing other stuff. And don't take away from it from other people, or for other people, by doing those kinds of things. So I want people to ask questions and participate, but I don't want to spend time telling 28 people to pay attention. Okay? Like Stephen, he's a great attention payer, right? Here's your moment to shine. Okay. Let's talk about kind of a vocab word. So there's this number. This number is going to be called the multiplicative inverse. Okay. In multiplication, there's this one special number, which is called the identity. It's the number 1. The number 1 is the identity element for multiplication because when you multiply by 1, what happens? You just get the same number that you multiplied 1 by. Okay? So, but that's not the multiplicative inverse. What happens with the multiplicative inverse, when you multiply 8 by that number, you get that special number 1, that identity element. Okay, so what would you multiply 8 by to get 1? 8 times this thing is 1. What's that?
1.
Multiply 8 by 1 and you get 1?
No.
Multiply 8 by 1, you get 8. it helps, you can think of 8 as 8 over 1, right? What would you multiply 8 over 1 by to get?
1 over 8.
1 over 8. Because we could write 8 as a fraction, 8 over 1. We can multiply straight across, we get 8 over 8. We get 8 multiplied by 1/8 is the same as divided by 8. 8 divided by 8 is 1. Okay. What's the multiplicative inverse of -4? What turns -4 into +1 when you multiply?
4.
-4 times 4, -16. What's that? -4. -4 times -4 is +16. We're trying to get 1 here. Ethan? Yeah.
-1 over 4.
-1 over 4. Because again, you could write this as over 1, if you want to. So when we multiply negative times negative, we get positive. 4 times 1 is 4. 1 times 4 is 4. We get 4 over 4, which is 1. What's the multiplicative inverse of -3/7?
-7 over 3.
-7 over 3. All right, we get 21 over 21, and negative times negative is positive, so that gives us 1. Do you know another word for these numbers that we're finding?
Reciprocal.
The reciprocal. So the multiplicative inverse, or the reciprocal. It's an important number, and really, what we are going to learn, what we have learned before, what we knew is when we divide by a number, division is defined as multiplication by the multiplicative inverse of that number. So if you're doing 7 divided by 5, that's technically 7 times 1/5. You're multiplying by the multiplicative inverse of 5, which is 1/5. Now, that's particularly useful when we divide by numbers that aren't so easy as 5 or 8 or something like that. We divide by fractions. If we divide by a fraction, we get to instead multiply by the multiplicative inverse, or the reciprocal. So we take 3/4 divided by 6/7, let's say. Well, we all know that we multiply by the reciprocal. The reciprocal of what? Multiply what by the reciprocal of what? What about 6? Is that the reciprocal? The reciprocal of that? So the reciprocal of that, so we multiply 3/4 by the reciprocal of 6/7, which is 7/6. 6 can cancel with 3. By the way, why does 3 cancel with 6? Goes into 6. Okay, we're going to talk about this in really specific terms here in a little bit. But sure, 3 goes into 6. Okay, 3 goes into 6. 3 divides 6. 3 divides 3 as well. So 1, that's 2. 7 or 8. There we go. Well, let's say it's safe. It should be safe to assume that we all already knew that we were supposed to multiply by the reciprocal. So I just want to remind you, I showed you this before, but to remind you just of a little confirmation that is what we're supposed to do. Okay. We want to multiply the numerator by the reciprocal of the denominator. That's what we want to do. We can prove that by saying that I can multiply a fraction by anything, but the numerator and the denominator by the same thing. Because really all this is one number divided by itself, so that's just 1. So we're just multiplying by 1. So if we multiply the denominator by its reciprocal, or its multiplicative inverse, these guys cancel, we get this over 1. Okay. What happens when you divide by 1?
It's the same number.
It's the same number. You take a number divided by 1, it doesn't change that number. Okay. So this is over 1. So when you have a denominator of 1, you don't really need to write that denominator of 1, right? All these numbers floating around are like over imaginary ones, but we don't write that. So that's nice. When you can get the denominator to be 1, you can stop writing that denominator if it's useful for you, which it is. It's nicer to write 3/4 times 7/6, what we see here in the numerator, and do some cancellation and carry the problem out to the end. Okay? So we're going to multiply the numerator by the reciprocal of the denominator. So why don't you get number 15, or do, no, not number 15, I want 2 fractions. Do number 17. Okay? So we want to multiply the numerator by the reciprocal of the denominator. Which of these is the denominator? 1 is the denominator? 1 over 5. There's lots of denominators. Maybe that was confusing. We've got one thing divided by another. If we were to write it as a numerator and denominator like a fraction, this would be the denominator. We're going to divide this by that. -1/2 divided by 1/5. I'll just show this again. You don't have to do this every time, but it's helpful. People who do write this down every time get these kinds of problems. This little error. Well, they don't make errors in that department. They multiply by the reciprocal in the correct way. So -5/2, and you can be done. Okay? So please don't do -2.5 because we don't need that. -2.5 as a mixed fraction. I've talked before about how that's nice if you want to get an idea of how big this number is. That's fine. And you want to gauge the scope of this problem. But if you ever want to add this fraction to another fraction, or you multiply this fraction by another fraction, it needs to be an improper fraction, or one number over the other. Ethan?
So it's okay if it's an improper fraction, then you don't want us to change it to?
Yeah,
Makes sense?
that's fine.
Okay.
Because the other number might be proper, but this one is the most useful.
Okay.
You never use a mixed number, right?
Mhm.
Now, if I want to get an idea of how big it is, if this were an actual quantity, like some number of gallons or miles or hours, that would make sense. Let's talk about -2.5. -2.5 gallons. I don't know.
Can we turn it into a proper fraction though?
Sure, you can. It's just the thing is, if I want to take this and then I want to further use it in another calculation, I just have to put it back into an improper fraction. Yeah. Sure. Yeah. Right.
Yeah.
All right. Okay. another, well, I guess an application of division is something called the arithmetic mean. And yeah, the book just talks about this like you've always heard about this. There's mean and there's two other ones that go along with mean a lot. Median and mode, right? What's median? Nathan?
The middle number.
The middle number.
Well, like you put them all in order.
You have in order. Yeah. And the number in the middle, or if there is no middle number, you take the arithmetic mean of the two. Take the average. Right? Then there's mode. What's mode? Dr. Connor?
You subtract the biggest number minus the smallest number.
That's the range.
The great,
What?
most common.
Most common, yeah. You just look at this set of data and you find the one that shows up the most, that's the mode.
I just saw it.
Okay? Now there's mean. They just say mean, they don't even tell you that there's other means. There's a geometric mean. There's an arithmetic mean. There's this mean that we're going to talk about. And if you know how to find the mean as in mean, median, and mode, that's it. You know how to find the arithmetic mean. That's what it is. Okay? So if you want to find the arithmetic mean, as in the example 3 on page 104, we give some temperatures over 5 days. Negative 21, negative 29, negative 39, negative 39 again, negative 22. So if you want to, over these 5 days, get an idea about how cold it was over those 5 days, we might take the arithmetic mean. And I'll ask you a question about mean in just a minute. So how do we find the arithmetic mean? How do we find the mean as in mean, median, and mode? For some new basics. Whoa. Caitlin?
You add them all together and then subtract, or divide by 5.
By 5 because?
Yeah,
There's
there's 5 numbers.
5 numbers. Alright, so you add them all up, which means negative 21, minus 29, minus 39, minus 39, minus 22. Okay? So if you're doing that, let me ask you this. I'll take my calculator, and I'll start with negative 21, and then I'll subtract 29, and I'll subtract 39, and I'll subtract 39 again, subtract 22. Okay? If I hit enter, will it do that correctly? Will it find that minus that, minus that, minus that? It's not a trick question. It will do it. I just said minus, 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 minus those numbers. It will find the difference. Whether the sum of this negative number and these negative numbers. Okay, so then I want to divide by what?
5.
Divide by 5. So I said divide by 5. Okay. Up to here, we were right. Like if we were to hit enter back there before I said divide by 5, it would have found that. It would have found the sum of those numbers just fine. Okay. So if I divide that by 5, the way it's entered, the way it looks right now, will it give me the arithmetic mean? Or will it give me something else? What will it give me? Well, don't tell me the number. Like what?
Not the range.
Why won't it give you the right answer? Why not?
Because it's going to divide through.
What's that?
It's going to divide through.
Why? Well,
Because dividing before adding.
and it follows our order of operations. Okay. So these Texas Instrument people made this calculator. A very popular order of operations is the one that we use in this class. This calculator follows it very strictly. It would divide. Well, this is even minus. This doesn't recognize this as the number negative 22 because I said minus 22 rather than plus negative 22. Okay, so it'll take positive 22 actually and divide it by 5. Okay, it'll subtract that from 30. Well, it'll do this subtraction up to here and then subtract 22 over 5. Okay, that's not what I want. I wanted to take all those numbers. This minus this minus this minus this minus this, and divide all that by 5. So, without hitting enter in between, how do I force it to do that first and then divide by 5? Nathan again.
Okay, do you like take all the numbers like minus and or whatever, and then you press enter, and then you divide that, like.
Oh,
last
but I
one
said
by five.
without pressing enter
Oh, then never mind.
in the single line. Derek?
Could have been parentheses.
Sure. Okay. And probably most of you are familiar with this calculator because it's pretty beefy. But if I were to squeeze, if I just press like parentheses, it'll just erase that negative and put a parentheses in its place. So if I want to squeeze it in there, I hit second INS, that's insert, and then I do that. I guess I should come down here. I want to squeeze a parentheses in there. Now I'm grouping all these 5 numbers together. It'll do that first, then it'll divide the result by 5. So we have negative 30 is the arithmetic mean of those temperatures. Okay. Now be careful about calling this the average. Lots of people call this the average. Average is just a word we use to say we're talking about central tendency. And there's 3 that we are familiar with, mean, median, and mode. Those are all averages. They're kind of like some kind of average. Okay. This is what people most often just call the average, but it's called the arithmetic mean. Okay. So if I talk about the mean number, I mean you add them up and you divide by however many numbers there are. Okay? So I'm going to ask you a question. I want you to think about this, and it's about arithmetic mean. Okay? So, and probability, and likelihood. Okay? And I just want you to think of some kind of a response to this in your own mind for, 15, 20 seconds. So, how likely is it, very likely or not very likely, that the next person you meet will have a number of arms that is greater than the mean number of arms? It's not a play on words, I mean the average. So the next person you meet has more arms than, quote, average. Than this average right here, this kind of average. So again, is it likely or not very likely that the next person you meet will have more than a, quote, average number of arms? Likely or not likely? Well, if we use the mean as the average, the arithmetic mean, okay? So we take up all the numbers of arms on all people, right? And then divide by what? The number of people. Okay, so like 6 billion people. All right, what are some numbers of arms that people have? 2, pretty common. 1, maybe. How about 0? Some people have 0 arms. How about 3?
That's possible if you have an accident.
If you got an accident, you wind up with more arms.
Like an experimental accident or something.
Okay, we live in reality.
That could happen.
All right. If you ever meet anyone like that in your actual life, you let me know.
Okay.
But no one I've ever met, okay, had that happen. No one I've ever heard of had that happen. So, 0, 1, and 2. Some people maybe 3. Are they fully functional arms? Probably. No, but even if, let's say that we count them as 3 arms. Okay. Do you think there are more people with 3 arms or more people with 1 arm? 1 arm. You have 2 probably, and you lost 1, or sometimes you're born without arms. That'll happen from time to time. So that'll happen, yeah.
What if you have a tail? Does that count?
No, doesn't count. It's an appendage, but not an arm.
What if you have a finger?
It wouldn't count.
Wouldn't count?
Wouldn't
Still
count.
on.
All right.
4 fingers.
No. All right. Let's stay focused here. So you got 0 armed people and 1 armed people and a lot of 2 armed people. And if we took the mean of that, okay, what would that number be, or what would it be close to? Close to 2. Would it be more than 2 or less than 2? It would be less than 2. Those people with 1 and 0 arms are going to bring down the mean. And so, do you have a number of arms that's greater than the mean or less? Greater. You have more than an average number of arms because those people with 1 and 0 arms are bringing it down, right? the average number of arms is less than 2, and you have exactly 2, and so you have more than an average. And the next person you meet probably has 2, and therefore has more than the average number of arms. Okay? So that's a less than. But if it was the mode, right, that would be something else. If we use the mode as our average, not the mean, but we use the mode, then what would the mode be? 2. Definitely, most people on planet Earth have 2 arms. Okay, anyway, we're not even talking about mean, median, mode. We're just talking about arithmetic mean. One application of division. Right. So here comes our most in-depth discussion. It's about fractions. It's about factors. And if you pay attention now and you take good notes and maybe you go back and review, you're going to be in really good shape. If you don't pay attention because you think you know it or you don't want to know it, then you won't know it. Okay? The mistakes I'm trying to highlight here will happen so often, but not to people who truly grasp what I'm saying here. Okay? It's a lot to take in, so let's all buckle in and ask questions and answer questions as well. Okay? First, we're going to start out with a fraction that can be simplified, and we're going to talk about why we can simplify it. Then we're going to try and expand that to broader horizons. How about 6 over 9? It's a fraction. Can we simplify it? We all know that we can. We can't do it. We know what we should wind up with. Like, that's not the focus here. The answer to how to simplify this is very boring. What is the simplified version? We already know it, okay? So, with that in mind, what is the simplified version of this fraction? 2 over 3, okay. We got that. We've had that for a very long time, okay? All right, so we're going to talk about it, and we're going to pull out really specific math words and vocab and be really intentional about the words that we use. So, what are we canceling out? What are we simplifying? What's happening that we get from 6/9 to 2/3? Easy.
We're dividing 6 and 9 by 3.
Good. We're dividing 6 and 9 by 3. Okay? We divide that by 3, we divide that by 3, and both of them, 3 goes, let's say that it goes into them evenly, right? Good enough? Goes into them evenly. That's something we've heard before. Okay. So we divide them by 3 because 3 is what? How is 3 related to 6, and how is 3 also related to 9? Goes into I saw someone speak at a lecture for teachers. Teachers go and they try to learn things as well. And she made fun of us for saying goes into, right? 3 goes into 6. What does that mean, right? To define things really specifically is really important. And what she was saying is really like we're lying to our students in a way to say goes into. Right? We use this intuitive notion and we don't define it mathematically. Okay, so goes into. What does it mean? It goes into it. It's kind of a hard thing to define. So how about we finish the sentence? 3 is a blank of 6. A factor. It's a factor. How do we define a factor? 3 is a factor of 6. Like, what's the proof that 3 is a factor of 6? Yes, 3 times 2. We're getting somewhere. 3 times 2 is 6, and also 3 times 3 is 9. So 6 and 9 have both have a common factor of 3. Okay, so what we really have, okay, for paying attention, is a fraction 3/3 times 2/3, right? Can't they be separated because we multiply fractions straight across, so we could also separate them into 2 fractions that if we multiply them together we get 6/9. And 3 divided by 3 is 1, and 1 times 2/3 is 2/3. Are you all with me
Yes.
so far? Okay, so here's a really important thing. To simplify a fraction. The numerator and denominator must have what? Common factor. They can have one common factor, they can have several common factors. We can cancel out all the factors that they have in common. Okay? Trust me when I tell you that if we break this down and you understand why it's so important that I keep harping on the word factor and the words numerator and denominator, it'll be really helpful in the future when we come back to stuff like this, okay? So it's really important that we talk about the numerator, not a number in the numerator, not part of the numerator, but the entire numerator, and also the entire denominator have common factors, or a common factor. So let's talk about a factor. What is a factor? What does it mean to call something a factor or something else? We've already kind of talked about it. What does it mean to call something a factor or something else? Well, let's see now. We're going back to these intuitive. I know what it means, but I don't know how to define it. What it goes into. What's that? No, what'd you say? You did just say it again. Because there's multiplying. It's very simple. There's multiplying. Okay? Let's say you. Okay, if you were a number. You would be a factor of another number if what? Connor?
Excuse the interruption. JV football players are repeating.
Goodbye.
Thank you.
Try and learn this on the bus. Scram! Beat it! Get out of here! Move! You're welcome to come back. I can't believe it. Okay, I'm gonna rephrase it when all these football players beat it. Okay. Alright, thanks. Goodbye. Get out of here. Okay. So let's say you are a number. So you are a factor of some other number if what? Connor?
You can be multiplied by a number two.
Simple as that. If you can be multiplied by another number to get that whatever number you're said to be a factor of. Okay. So let's say two factors multiply to produce the multiple. Okay. You might think, gosh, I've known that for 100 years. I don't need you to tell me that again. But the fact that they have to be multiplied is key, and that fact is lost so often that it bears repeating. Okay? So two factors multiply to produce the multiple. They don't add, they don't subtract, and they don't divide, and they don't raise to powers. Well, I guess you could raise things to powers, that's multiplication. But it's strictly multiplication. If you multiply one number by another, they're factors of whatever they made together. Okay. So, that's going to bring us to this problem, which if it's possible to have absorbed that and to synthesize it to all new different kinds of problems, then you'll do great. But you could likely make the common mistake here. So I just want to say, take a look at that. These are the kinds of things we want to be able to simplify in this section and in future sections as well. So I'm going to ask you, can you simplify this? Can you simplify this expression? You cross something out and write something new. Okay. So I want you to look at it, simplify it if you think you can, leave it alone if you think you can't. Remembering, if you were to cancel They must have a common factor, and a factor means to multiply. Okay, underline the words numerator and denominator, not some numbers. So who thinks you can simplify this? It's possible to cross something out, and you just have a new thing. Who thinks you cannot simplify this? Like one person, and the rest of you don't have opinions. Okay, just wait to see what happens, plain and simple. Well, here's what I'm sure everyone who thinks you can simplify this has done. You've done this, and you did probably x plus 1. Not correct. Okay, it is the most common desire. Okay, oh, I just remembered I have this. Okay, so I have to, I'm going to see if I can find it. Here they are. Yes. I'll share this with you once we get done. Okay. So we're going to learn that you can't do that, and hopefully what we'll learn is why you can't do that. Question?
Why did you cross out the equal sign? It doesn't work.
Because it's not, you can't do it. They're not equal.
Okay. Okay.
So if you crossed out the 2's and got x plus 1, no, you can't do it. And I'll show you why. Okay? And it comes down to all those words that I underlined and put in boxes. Numerator, denominator, factor. The numerator and denominator. Okay? What's the numerator? What's the numerator of a fraction? What does that mean? The top number. Whatever it looks like, that's the top number. So what's the numerator of this fraction? X plus 2. Not x and not 2, but x plus 2. The whole thing. Okay? So if I wanted to cancel something out with the numerator, then the numerator would have to have a factor of whatever that is. Okay? Which means, let's look at this problem. Let's write it down again. X plus 2 over 2. Let's say if we wanted to cancel this 2 with something up here. Okay? Maybe it's possible, but here's what would have to be true. We'd have to rewrite this in this way. Just like we had 6 over 9, we wrote this as 3 times 2 and 3 times 3, right? And then we were able to cancel this factor, 3 times 2, 3 times 2, with this factor, 3 times 3. That's what we have to have, factors. So if we're going to cancel out, let's say we're going to cancel out this 2 with something up here. That means that there's a factor of 2 up here, which means there's a 2 that we're going to cancel out. Okay? A 2 times something. Okay? And when we multiply this 2 times something, what would that have to be equal to? It would have to be x plus 2, because that's where it came from. Well, I guess in a way we could do this, but what would we have to put in these parentheses in order for the 2 here to distribute into the parentheses and wind up with x plus 2?
Put x in the parentheses.
Just x?
Yeah, then you get another 2x. Sure, the property.
Yeah, I get 2x, but do I get x plus 2? Are 2x and x plus 2 the same? This is 2 times x, that's x plus. Okay?
X plus 2?
Put x plus 2 in the parentheses? X plus 2 in the parentheses. Whoa. What are we going to get? 2x plus 4. That's not x plus 2. When we distribute this 2, we have to wind up back at x plus 2. Have you figured anything out yet?
X plus 1?
X plus 1, not a bad idea, because if I have a 1 there, I'll wind up with a 2. But x, or 2 times x will give me 2x, not 1x. Yes?
Wouldn't it just be like 1x?
Wouldn't what be like 1x?
So it's just 1.
So just put a 1x in there. Put a 1x. Okay, and I'll just do 2 times 1x, which is 2 times x. But we wanted 2 plus x, or x plus 2. Is it working? Are we able to write it this way? Is what I'm trying to get at.
No.
No. So the answer is no. And so the answer to this question is very important. Is 2 a factor of the numerator? How do we know that? How did we show that? How did we just prove that? That it's not a factor of the numerator. How do we know it's not a factor of the numerator? We couldn't fill in those parentheses. That's what it was. 2 is clearly not a factor of x plus 2 because when we went to write it as 2 times something, which is what needs to be true if 2 is a factor, we couldn't fill it in. We couldn't put things in here so that when we distributed the 2, we wind up with x plus 2. Okay? So 2 is not a factor of the numerator. So this is what it comes down to. If the thing you want to cross out, that you want to cancel, is a factor, you should be able to write it this way, and then you'll be able to cross it out. Now, so what if we change it? I'll write the new part in blue. What if we put a 4 there? Now can we fill in these parentheses so it comes out right? What can we put in the parentheses? 2x plus 1. 4x plus 2. Exactly what we see there. So, is 2 a factor of 4x plus 2? Yes, because 2 times 2x plus 1, this other number, even though this other number looks kind of weird at 2x plus 1, it's all in parentheses. It is one number, it's grouped together, it's another number. So 2 times another number gives us the numerator, so 2 is a factor of the numerator. So now that we have common factors of 2, we can get 2x plus 1. I know that's a big long explanation and it seems so technical and nitpicky, but this is, I hope this isn't true. But if it is, I wouldn't want to be responsible for the outcome. It's kind of small. Try that. See what it says?
Which one because the kitten dies?
Right. Every time you try to cancel things out like this, like you just tried here, to cancel a 2 with that 2, kitten dies. Okay? You don't want that to happen.
I'm sure that's not true.
He looks very scared
Alex
of you doing that.
Don't kill kittens.
So be careful when you're simplifying expressions like this. This one's a bit more complicated than ones that we would use on a regular basis. But see, they're crossing out this x squared and this x squared. Why? Because they want to. They see an x squared and an x squared and they really want to cross it out. They really want to make it look simpler. But it's not right. It's not x squared times the rest of this stuff. It's x squared plus all that other stuff. So x squared isn't necessarily a factor of the numerator, so you can't necessarily cross it out. Okay? So just hopefully a humorous reminder to make sure we're looking for common factors, not just numbers that look the same, but common factors. Okay, so that said, let's do number 37. Simplify it if you can, cross out common factors if possible, and if not, you just leave them. Cross something out, prove that you can by writing, showing that it's a factor in the numerator as well. I see a lot of this. 10, crossing out to 5, kitten dies. Because though 5 is a factor of 10 and it's a factor of 5, is it a factor of the numerator? Maybe it is, I'm not saying it's not, but I'm saying that just crossing that 5 out, that 5 right there is not a factor that we're looking for. That's just a number that has another number subtracted from it. If that 5 were a factor that we were crossing out, it would be 5 minus 25 cubed. If it was a factor, what would we see? 5. What about factors? 5's a factor if it's 5. What's that? What is with the T? Times. Is it 5 times? Other stuff? No, it's 5 minus 25 cubed. But if we could write it as 5 times something, even if that something is weird looking and it's inside parentheses, 5 times one other thing, then it would be a factor. That's what we have to do before we can just cross it out. So, right now, as it's not completely obvious, that's what we should do. We should write it just like that so we can see if it's a factor. Okay? So, suspicion is that 5 is a factor of the numerator. Maybe we can cross 5 out. If we can, then it needs to be a factor, which means we need to be able to write it as 5 times stuff. Okay? Can we fill this in with some stuff so that when we distribute the 5, we get 5 minus 25 cubed? Let's think. Distribute the 5 to this first thing, and you should get 5. So what would that first thing have to be? Nathan?
Negative 5q.
Just negative 5 cubed?
Yeah, I don't know.
Well, that's something. We're closer. 5 times negative 5 cubed gives you what? Negative 25 cubed, but we need 5 minus 25 cubed. So we've got part of it, we just need a little more. Nathan?
1 minus 5q.
1 minus 5q, let's check that out. 5 times 1 is 5. 5 times negative 5q is negative 25q. All over 10. Okay, now, have we identified 5 as a factor of the numerator? Yes, and when we do that, and we cross out that 5, we haven't just crossed this 5 out, or just the 5 out of the 25 out. And the truth is, if you're going to cross out a 5, it's the same as what we're doing here. You need to be able to cross a 5 out from here, and here, and here, and any other term that you see in the numerator and the denominator. All of the terms have to have it in common. It's the only way it can be a factor of everything. It needs to be a factor of every term. So we could do it differently. We can come down here and say, well, cross it out here, here, and here. Then I cross 5, divide this by 5, I get 2. Divide this by 5, I get 1. Divide this by 5, I get 5. So I get 1 minus 5q over 2. Another way to put it. Does multiplication distribute across parentheses? Do you use distributive law on multiplication? Yes, yes we do. We were trying to do it in reverse here. We knew it had to distribute over the parentheses. Okay. Well, division is just multiplication by the reciprocal, so division also distributes across the parentheses. So 5 minus 25q over 10, the division by 10 distributes across everything in the numerator. 5 divided by 10 minus 25q divided by 10. So 5/10 becomes 1/2 minus, now 25 and 10 share a factor of 5. So we get 5q over 2. Should be a fine way to write it as well. You can finish out your answer that way. More commonly, we'll wind up with something like this later on in math, but this works fine too. And when we do the simplification, it will always happen that they have common denominators, but these do happen to have common denominators, so we could just put them back together if we wanted to, right? 1 minus 5q over the common denominator 2. So in the end, when we try to simplify these, the key thing is don't just cross out things because they look the same, or they're factors of some part of the numerator and some part of the denominator. We have to include the entire numerator, the entire denominator. Okay. Well, what I will do now, there's your homework. It's just 2.6. That's all it is. I want to at least start a video that I think is pretty entertaining. You're going to have to watch a commercial.
It's only 2.6.
It's only 2.6.
Oh, here she comes. She's a scary lady.
Hey, we'll skip that.
Zero is a perfectly good number and you ignore it at your peril. The problem is, it's a dangerous number. And a lot of things can go horribly wrong with zero. Because it is a slightly more unusual, nuanced number, you have to be more careful with how you handle it. And so there are some things that you can't do with it. So you can't divide something by zero, and you can't have things like 0 to the power of 0. I mean, I get asked about these all the time. People are constantly, why can't I divide by 0? I want to divide by 0. Isn't it just infinity? Blah, blah, blah. And so I thought I would do two things. First of all, I'm going to show you why no, you cannot divide by 0. It's not just infinity. It's a bit more complicated than that. And then I'm also going to look at why you can't have 0 to the power of 0.
Okay, so this is something that we've been asked a lot at number 5. Well, you may know that something like multiplication is just glorified adding, really. If you want to do 5 times 10, you just add on 5 plus 5 plus 5 plus 5 10 times. Division is just glorified subtraction. So if I want to take a number like 20 and then divide it by 4, I just keep subtracting 4. So you take away 4, take away 4, take away 4. You do that 5 times, and that number 5, that's your answer. 20 divided by 4 is equal to 5. So it's just glorified subtraction. That's really what it is. Now, if I divide by 0, then that means I'm subtracting 0 over and over. So 20 divided by 0 means I take away 0, I've got 20. And then I take away 0 again, I've still got 20. And I take away 0 and 0. And that would go on forever. You would never get very far doing something like that. Keep taking away 0. So 20 divided by 0, that's infinity, isn't it? Surely it's infinity. And that's what I expect people to think, right? Surely only a nerd would tell you differently. That's when you cut them out, tell them different.
So first of all, everyone goes, why can't you just say that something divided by 0? So let's say I'm going to do a function. I'm going to have a function of 1 over x.
We don't say something is equal to infinity, okay? So infinity is not a number and it can't be treated like a number, okay? It's an idea. So we can't say 1 divided by 0 equals infinity. We can no more say that than we can say 1 divided by 0 is equal to blue. Alright, but if I am naughty, right, and I do this, 1 divided by 0 is equal to infinity, you would get just as equally 2 divided by 0 equal to infinity. And obviously you get the problem here that 1 seems to be equal to 2. Obviously that's nonsense, and that's why we don't. So for a very good reason, we don't say it's equal to infinity. You're going to get nonsense like 1 equals 2.
But let's say, what if you take a limit? What if you just take the limit as x gets really close to 0? Doesn't this equal infinity? And so you would say that actually dividing by 0, you could therefore conclude that 1 divided by 0 equals infinity. And I'm going to show you why you can't do that. So if you imagine your number line here, so this is the number line. I'm going to put 0 right there. So there's 0 in the middle, and now here this might be 1, and then so on all the way up. And as you go along, this here, I'm going to draw on this axis going up. This here is my 1 over x. I'm going to have 1 over x on that. And over here, when it's 1, this would be about 1 there. When you come back to, let's say, about a half, This is going to be a bit bigger. It's going to be twice as big. By the time you get down to about a quarter, that's going to be twice as big again. If you come, and as you get closer and closer, I absolutely agree, this gets bigger and bigger, this goes racing off, and it does tend to infinity. This is absolutely correct. But this only works if you're approaching zero from the positive numbers, if you're coming in from the right on your number line. If you come in from the left, it's completely different. So if you start over here at -1, then your value is actually down here at 1. If you then go to -0.5, it's down here at -2. And then you get closer and closer, the value goes racing off in this direction. In fact, it goes racing down to negative infinity. So yes, if you approach zero from one direction, you get infinity. But if you come in a different way to exactly the same place, you get, well, you can't get much more different than negative infinity, and people will yell at me if I say it's infinitely different from positive infinity. Well, maybe this line goes all the way around and wraps around the entire universe and then comes back up here. But as far as I'm concerned, if you come in from one direction, you get one answer. If you come in from the other direction, you get a different answer. You're going to the same place. There is no one limit of, as you get closer and closer to dividing by zero, there's more than one limit with completely different answers. And that's why we say it's undefined. Mathematically, what we would say is we say, I won't blue this time, sorry. If you approach the limit as x approaches zero from the positive direction equals positive infinity, and then separately, down here, the limit as x approaches zero from the negative direction of 1 over x equals negative infinity. And these are different, they equal different things. We simply cannot just assume that 1 over 0 equals infinity.
If you go to 0 from this direction, it's going off to plus infinity. And if you go to 0 from this direction, it goes off to minus infinity. Two different answers.
When I type 1 divided by 0 into my calculator or my computer, it can't do it, it can't handle it. What's it trying to do though? What can it not do? What happens in those circuits? What did it try and fail to do? Or has the calculator been taught?
Oh, that's a very good question. Is it attempting to do something and then it's not getting an answer? Or has it just been taught to divide by 0? I honestly don't know. I suspect it's just been taught that if someone hits divide by 0, say error, or what it might do is actually try to get to that answer by an iterative process, which it then finds exploding in one direction or the other, and so it's got some kind of built-in cap or some kind of safety switch which goes off to say this calculation is getting out of control, call it off here, just say maths error. So I imagine it might even vary from device to device, so it'll be one of the two.
That's
the other thing
dividing by
that people
0.
get very annoyed about is when you...
0 to the 0 power, which we don't have to worry about.
Let's find this distributive chapter. Divide by 0.
Yeah. And actually,